Welcome everyone. I am Sean Sainamore. I get to manage the controls tonight while Zach Semke is at Terrytown at FIASCon. Hold on one second as I do one more screen share. Let me get out of that and I want to pop up. Zach does this so well and I appreciate what he does because it takes a bit of effort to manage all the different screens. So we have the Vancouver Firehall number 17 that we are going to dive into, and you are attending the Global Passive House Showcase. It could be Wednesday evening or it could be Thursday morning, depending on where you are on this planet. So thank you for joining us. And we have a fantastic guest host tonight. And so I will turn it over to, are you there, Louise? Come on, turn your mic on and get the show started.
Yeah, I'm here, buddy. Thank you. Thank you. First of all, for those of you who don't know me, my name is Luis Bezerra. I'm the Manager of Education, Training, and Development with Passive House Canada. And I'd like to thank the Passive House Accelerator for the invitation to be your guest host today. For those who may not know who the Passive House Canada is, we're the Canadian affiliate of the Passive House Institute. And our focus is to broaden and include advocacy, education, and professional development throughout events and technical services. We have over 3,000 members nationwide, and we're one of the largest passive house training institutes all over the globe, with over 1,500 students in our programs only in 2021. And we have now over 200 students becoming certified passive house designers, consultants, and tradespeople. If you're interested in learning more about us, visit our website, passivehousecanada.com. And before introducing our presenter today, I want to congratulate all of those involved here in the Vancouver Firehall number 17, and to all of you here today. I wrote a few words here, guys. I mean, like my English is my second language, but it's something that really touches me, and it's something that I think about all the time. That the changes we make today, we shape the future of our planet. So Harvey, that's for you, man. Let's not ask how much it costs. Let's ask how it's done. Will the decision help us moving forward and being able to save our planet? This group has the power, strength, and resilience to make necessary changes to shape a better future for our planet. This project shows, once again, anything can be achieved. And if there's will and effort, we'll get it done. Let's not reinvent the wheel. Let's make the wheel spin faster. There is a quote I like repeating to myself over and over when I'm working. So alone you go faster, but together we go further. And here's food for thought before I introduce Scott and his great project. If countries such as Canada, US, Germany, France, the ones with the big economy, if we can make the necessary changes due to budget, have you guys thought about the poor countries? I mean, like I come from Brazil, so I know there's a big change comparing those different reality. But now let's talk about what it's we're all here for. And I'd like to introduce Scott. So with over 11 years of experience, the Scott Rabo's project and stakeholder management experience have allowed him to successfully deliver across multiple sectors, including institutional, aviation, cultural, civic, and emergency services. Guys, you better pay attention to him today. With a passion for sustainability and emphasis on integrated design, he thrives to develop resilient and regenerative design solutions that go beyond the client's triple bottom lines, as evidenced through his notable projects, which includes the Vancouver Firehall number 17, redevelopment, zero carbon certified, and PH pre-certified, and the Vancouver International Airport's PRD expansion. As a certified passive house designer, Scott has been involved in numerous integral passive house projects in roles that include design and technical advising. He's also part-time instructor at the BCIT Passive House Tradesperson's course, where he endeavors to bridge the gap between mechanical design and construction practices that would enable the trades to build high-performance buildings. So, our project today, while regional policies are becoming more stringent for sustainable building performance, local authorities' public projects are often used to showcase high sustainability standards and achievements. Scott will share, through a mechanical engineer lens, his experience on Vancouver Firehall number 17 project targeting passive house certification, the GAGBC Zero Carbon Building Program Lead 4, and Net Zero Energy as defined by FCM. He will share his insight into the decision-making and the design process, as well lessons learned that lead to one of the highest performance fire halls in North America. And I'd like now to welcome Scott into the show.
Thank you, Louise. Thank you, Sean. That was a great intro and some great words to share, by the way. I really like the inspirational portion at the beginning there. Hello, everybody. Bear with me as I just share my screen here with you. Maybe give me the thumbs up, Louise, if you're good to see that.
Yes, Scott, we can see, just need now to the presenter mode.
All right, excellent.
There we go.
So thank you everyone for joining us today. As Louise mentioned, you know, this here is a project that's been long in the making. I remember first starting design on this back in 2016. It's been nearly 6 years now, and we're about to cross the finish line on it. So I really appreciate everyone making the time to kind of learn about its story, its narrative, because it is quite an interesting one. Because at the time when we first started, this was the city of Vancouver's first kind of dabblings into passive house. In fact, this was going to be their first non-residential passive house project. And what you'll learn today, and possibly maybe you've seen this previously in preceding presentations on this project, but fire halls are not, you know, simple buildings. They're actually quite complex archetypes. They mesh together this residential component, this commercial, you know, office component, in between all this utilitarian and very industrial space. So there's a lot of process loads. There's a lot of energy that's being consumed in these fire halls, and so they're ripe for turning into high performing buildings. And personally, I've worked on many of fire halls in my time, and it was through years and years of working on various different fire halls that we were able to kind of learn some great lessons learned that we tried to apply here. And so if you want to, like Louise mentioned, take a dive into, you know, into this project, particularly through the mechanical engineer's lens. Hopefully we can share, you know, some lessons learned, some challenges, some solutions, and I got some great pictures from site to be able to share as well. So like I mentioned before, this was the city's very first passive house project. It was also, you know, the city of Vancouver also has a really robust green building policy. So all new buildings needed to be LEED gold. But it was very clear that as we started designing the building and through some of our previous experience, we knew that we'd be probably able to manage the loads to a point where we can even widen the scope of the sustainability objectives on this project to eventually incorporate the zero carbon, which at the time was a pilot program, and this was one of the first projects to apply for it. Primarily because for us in the Pacific Northwest, and particularly in Vancouver, electricity is fairly carbon free, not entirely carbon free, but fairly carbon free. So it was quite an easy step for us to widen that scope to include that. And then inherently, by taking such an aggressive measure through the envelope first approach of passive house to reduce energy, and then through some really interesting ways of designing systems to further reduce energy on the building, consider, you know, the possibilities of actually going net zero in energy. So, you know, this is a project with a few different accolades that it's hoping to achieve under its belt, but probably the one that takes the cake for the hardest was passive house. So before we dive right into the systems discussion, it's important to take a bit of a step back and really understand, you know, fire halls and why they're such big energy pigs, right? You know, the average here across all of City of Vancouver's portfolio shows that, you know, the PER for these buildings is actually quite high. In fact, it's egregiously high. For buildings that are often, you know, on average can range anywhere between 15 to about 20,000 square foot, right? And a significant portion of that hall space is actually dedicated to double height, you know, apparatus-based storage, which isn't even tempered to a full 20 degrees. So it helps paint a bit of a picture for you to understand that, you know, there's a lot of different process loads and energy being consumed in these halls. And so with our fire hall, the existing fire hall at the time in 1954, you know, postmodern building that, you know, was probably one of the worst offenders, to kind of make the jump over into, you know, the passive house realm, which was practically, you know, an 80% cut. It's quite significant. And we knew that we had to do everything that we could from the envelope perspective, and HCMA, I think, did a fantastic job of addressing that, particularly considering as tight a site as we did have to work with. But we knew that the systems and the approaches for heat recovery and system selection were going to play a large role in tying the energy narrative in and finding solutions that were going to be quite fitting for this project. And so the system selection started with very simple conversations with the fire department and the owners. And for them, they had some very specific requirements, which were that they needed active cooling all throughout the year, particularly because of the fact that when firefighters return after a call, they're heat exhausted, they needed to be cooled, they needed the spaces to remain cool. And, you know, the average space temperatures of 20 to 25, you know, sometimes just wouldn't cut it. So they needed some spaces to be cooler than others. Noise mitigation was also another big thing for them. I'll share in the next slide a bit of a site shot for everyone to understand the context of that. But for those of you who do know this site quite well, it's off of Knight Street, which is a very busy thoroughfare. There's like semi trucks rolling through there at all times of the day and night. So not only for noise mitigation was particularly key for the firefighters themselves to be able to get rest, but also just being conscious of the noise the building itself generated for the neighbors around the area, because there was, in fact, for the most part, residential RS1, so a lot of single family residential around the area. So they had to be very conscious of that. And like I mentioned, the city of Vancouver being, you know, probably one of the most, you know, I guess, leading edge municipalities in the city within BC and really in North America, big emphasis on reducing carbon and really pushing the envelope, you know, pardon the pun, in finding ways of reducing their own footprint, and in doing so kind of tasked us with looking at low carbon solutions, which essentially right off the bat looked at, you know, natural gas free sources of heat, so looking at electric based systems. And so these big key requirements in the building essentially kind of pointed us down the path of electric-based, you know, heating and cooling systems, which inherently kind of lend themselves to heat pumps. And so, of course, you have, you know, the water to water, air to water, and air to refrigerant. And going through the pros and cons of each of these, we eventually settled on geo-exchange, and primarily for three key benefits in our that were kind of looked at across the board. And for the city and particularly the stakeholders, they understood the superior energy savings that can be realized through geo-exchange. You know, touching on the system resiliency aspect, you know, the big reason why you have greater levels of resiliency and energy savings is because you're sharing and exchanging heat and cooling with the ground, which is a lot more constant and a little less disturbed based on kind of your air to refrigerant or air to water systems, which rely on the outdoor air temperatures. But it has great noise mitigation opportunities because you no longer have these big outdoor units blowing at all times of the day and possibly causing a nuisance to the neighbors around them. But it also increases the service life of the equipment because everything's held indoors, nothing's being weathered over time. And so the maintenance people were particularly keen on that as well, because, you know, they didn't have to go up onto roofs to access any equipment. Everything was indoors in a nice, you know, thermally comfortable passive house for them to get access to. And a great thing about this project is, considering the geo-exchange field that's required for this project, you know, when you come to think about, you know, a passive house and really reducing the loads for this building for it's just about 19,000 square feet building, you know, really straddling the north and south lines of the property there, and with Knight Street on the diagonal on the left, we had a very narrow site to work with to actually install geo-exchange. And so, you know, based on our modeling for the heating and cooling needs of this entire building throughout the year, all it took for us was just 12 boreholes. And that right there is a great story. You know, there's no backup heating in this building at all. There's no backup boilers, no backup, you know, cooling towers or anything. The geoexchange field, in order to meet the 100% of the heating and cooling needs for this building, are just, you know, the small little portion of the site in the top left corner. Now, it being a very tight site as it was, we definitely talked to the city, and considering that we had a little bit more room to play with, we allowed for an additional 3 boreholes for a couple of reasons. The first one is just to mitigate some of the constructability risk with as tight a site as it was, to make sure that, you know, when we are digging, you know, about 300 feet down into the ground, if we hit a boulder, we have enough room to make up for an additional borehole here and there. And so that gave us the flexibility to do so. But it also gave us 30% more field space, which is actually kind of quite a big piece, particularly on the climate resiliency standpoint, because, you know, as temperatures get warmer outside, and yes, the ground is somewhat shielded from that, but, you know, your building is still experiencing that extra cooling demand. And so as a result, having some additional storage in the ground to be able to mitigate that just increases the service life of the field, which actually, you know, allows for this building to, you know, have a service life much greater than, you know, what it was initially forecasted for. Most buildings are often designed for 50, maybe 80 years. This building was looking to essentially hit 100 years of service life. Now you're probably wondering, well, Scott, there's tons of room on the site. Why don't you, you know, put a whole bunch of, you know, boreholes across the site? Well, that's a very good question. Anyone want to take a guess how many boreholes you'll actually need to do this building if it was a code building? You know, try to take a guess in the chat. You know, let's see who guesses this right. I'll give you a few seconds to put your number in. You know, people, I'm not seeing the chat move at all. So maybe everyone's, oh, I'm seeing a few come in. Okay, excellent. The correct answer for those that are probably, you know, put something down is roughly 70 boreholes. And you'd effectively be covering your entire site with boreholes. So in addition to the green and the blue, the green and the red ones, you'd need the extra blue boreholes in order to make up the entire site, or to meet the heating and cooling loads 100% of the year with the building of its equivalent. Now, you know, the city was very clear with us. They didn't want boreholes to be drilled underneath the building itself or in lanes where the trucks could be running. So that really narrowed up our field. And you know, one thing I didn't share with you, which, you know, is worth highlighting, is that a portion of the site was actually actively being used for the training facility, which was put in place directly next to the fire hall, so that, the temporary shelter for the firefighters themselves to remain in operation while they were building it right next door to them. So you can see in that image that it's a tight squeeze on site, and you can see right there just the very southern edge of the building itself, straddling the property line. So we weren't kidding when we said this was a tight site. So all we had was just that little sliver on the left side of the site to be able to fit our boreholes when we looked at this entire project. And I'm happy to report that, you know, with some careful spec and conversations with geoexchange contractors, that we were actually able to, you know, install each one of those boreholes in the exact locations that we had highlighted without any issues. Although, I mean, there was one issue, is actually the one at the very, you know, top left corner of the site, the one that's closest to that telephone pole, right at the corner of the edge of the site. And I think the only issue that they had was that they were a little worried that they were too close to that telephone pole, but it turned out that it was a bit of a non-issue anyway, and they were able to install it no problem. And the nice thing about this, you know, being such a discrete little site, is that each one of those boreholes are actually individually home run back to this one vault that's located in that bottom left corner there. That gives us the ability such that if any one of those boreholes is compromised, we could isolate that one borehole without impacting the rest of the field. Whereas larger fields, in order to help save cost, normally they're grouping all the pipes together. And so if one of those holes is compromised, you might see 4 or 5 of those go down, right? And so that gives us the ability of just really, you know, minimizing the downtime to the haul. It was a far more intuitive design that gave far greater resiliency to not just the firefighters, but the city of Vancouver, from a maintenance standpoint and long-term operational standpoint, and really a great story to share because the cost of doing the geo exchange on this building actually was quite close to the cost of putting all the PV that went onto the roof. So a huge win for us there. Now I want to transition a little bit more into a more passive element of the building that was integrated into the overall system design and the impact that it had there, and that was the use of electrochromic glass on the building. And so I mentioned that, especially on the south end of the building where we were straddling the south property line, fixed shading was a bit of an issue. And so we had to find ways of being able to mitigate, particularly the harmful gains in the summertime with, if I take a bit of a step back, you could see the amount of glazing that there was on that south facade. So we needed to be very conscious of that. And so electrochromic glass gave us the flexibility of being able to do that, but also just that flexibility in the shading options with its activation on and off between the winter and summer months. And that right there, between its full activation on and off, is quite substantial. It was able to just, right off the top, shave about 14% of the load on the mechanical systems, which again, gave us an opportunity to be able to look at, putting in, lighter grade equipment, which is a little bit more readily available rather than commercial or institutional grade equipment, which comes in the bigger sizes. So it increased our ability to find different equipment to spec, which made it a little bit more cost effective in that regard. But altogether, the costs there of just shaving wherever we could on the mechanical load allowed us to pay for some of these upgrades like electrochromic glass. And the neat thing that we did there, which at the time when we were in design was with View Glass, but ultimately Sage Glass was the successful proponent. Working with their teams, we know that this system could be integrated, like its controls algorithms were very simplistic in the sense that we can integrate them into the building control systems, because the way the system works is that it gets the sun shines on an irradiance sensor. Based on your exposure, it then says, all right, start tinting my glass, right? But we layered that into the building automation system such that we can look at harnessing the ability to turn on and off the shading based on our season. So depending on whether or not we're in the heating or cooling season, and in this case, if we're looking at the cooling season, we'd want to first look at activating the shading and waiting and actively allowing for the system to pause before activating any other type of system. And so if it's able to meet the space temperature or at least mitigate the gains such that our space temperature is satisfied, then we can sit back and relax. Otherwise, if it's not satisfied after a certain period of time, we can then look at boosting our HRVs if free cooling is an opportunity before actually activating our active form of cooling to then deal with any potential loads. And same holds true in the heating season, except it's slightly reversed, depending on whether or not you are, in this case, kind of looking at, deactivating the shading, and if it does help to mitigate the gains. Otherwise, you look at activating your fan coil units and dealing with it more actively. It's transitioning to passive house. And more so on the ventilation side of things, the one thing here that's worth sharing is that, here is a bit of just a very high level overview to help give you an understanding of how many heat recovery ventilators we had on the project, and B, how they were zoned. And what you'll come to realize is that, boy, there's a lot of HRVs on this project. What the heck were you thinking, Scott? I mentioned at the time that this project has been in the making for quite some time. And at the time that we started, you'd be happy to know that Swagon was just about to enter our market. And the only other passive house certified component that was anywhere near this level of performance or, could offer some form of performance to us were the Zender, Comfo Air 350s, which really weren't tasked with being able to kind of operate at the amount of airflows that we needed to find in a Firehall. And so we were really lucky that, Zender had brought in these units, and so we were able to design around that. But the one thing that wasn't in our advantage was that the react dampers weren't quite there. And so we zoned different spaces and occupancies based on their usage and occupancy patterns, so that the whole spaces or the whole zones could kind of ramp up and down based on, you know, peaks, the ebbs and flows of the occupancy throughout the space. And so, you know, the one benefit there too is that we also looked at decoupling our ventilation systems from our heating and cooling systems. So what that meant is that we ran separate ventilation ductwork than our heating and cooling equipment. So the heating and cooling equipment can recirculate and only operate when needed, whereas the ventilation systems operate all the time. And that gives us the opportunity to be able to significantly reduce the fan energy and a lot of that heating and cooling equipment because it's not needed to run to supplement the ventilation load to those spaces. But, you know, like I said, why so many units? It was largely because at the time when we were designing, you know, we were in the midst of kind of working through that market transformation. And it's really great to see that in the past few years, you know, we've seen other HRVs come to market, like Flackwood. We've seen, you know, Multicross start to dabble into. Oxygenate has units that are also available now. Same with Vantacity. So it's great to see a great slew and a wide variety of different manufacturers and manufacturers that have passive house certified components that can make, you know, bigger projects and more complex projects, or cater to those projects rather, a reality, because otherwise, you know, it definitely becomes a bit of a challenge to be able to design bigger buildings with just Comfort 350s. And one piece of the ventilation puzzle that I definitely want to share is the topic of kitchen exhaust. And when you consider the fact that you've got, you know, 10 firefighters, 2 shifts, and 3 solid meals a day. In fact, that's one thing that you'll probably realize ever walking into a fire hall. It always smells absolutely amazing in there because there's always someone cooking, you know, and making enough food to feed, you know, the lot. And so you're looking at, you know, a lot of different meals, up to 60 meals a day. And so, you know, the one thing that we learned particularly on fire halls is that, you know, you'd be surprised how many kitchen fires actually get started in fire halls. When a call comes in and someone's working that kitchen, you know, they're going to be leaving right away. And sometimes they forget to hit the button to shut off all the equipment, right? And so you'd be surprised to hear how many times people go, answer a call, come back, and they come to their own hall and there's a fire started and they need to kind of deal with that own with their own mess. But the big story, or what I was leading to, is the fact that for them, they're really trying to, you know, make a case that they did not want to run exhaust to the outdoors. Or sorry, they did want to run exhaust to the outdoors. They were not big fans of recirculating air in the space because of the amount of smoke and their previous you know, experiences. And so they were quite adamant that this was something that, you know, could not shift, and as a result, or they couldn't shift their paradigm away from. And so, you know, working with the team and knowing this information quite early, you know, we looked at the variant designs to be able to look at the impact that it had on the overall. And yes, though it had a significant impact on, you know, the heating demand, you know, the overall impact that it had on the overall primary energy was, you know, quite small in comparison. And so that was just one of those decisions that as a team, we decided to kind of design around. And so it just meant that, you know, we had to find other ways of making up for that energy penalty. And so we found ways of being able to kind of balance the load, particularly on the ventilation side, such that, you know, the HRV that serves that zone can remain a little unbalanced just during those times of extended cooking. Which, you know, actually is a bit of a positive effect, because oftentimes when they're cooking over long periods of time and they're generating a lot of heat and steam in that space, if they're able to run the HRV at a bit of an imbalance and bring in a little bit cooler air, it actually provides the firefighters with a bit of relief, because they actually prefer to have the space a bit cooler anyway during cooking. So that was, you know, one way that we were able to address that. And of course, you know, with the penetration to the outdoors, thermal bridge free design, and finding ways to mitigate those as much as possible. Well, you know, you'd be happy to know that there's, you know, tons of products that are available on the market to be able to address that. So that was one way we were able to look at, you know, finding ways to reduce that load as much as possible. And lastly, I'd like to touch on domestic hot water, because I think that's always, you know, when we start reducing the envelope loads, the ventilation loads, you know, the heating, cooling loads as much as possible, domestic hot water becomes the next kind of elephant in the room that we need to address. And similarly, when we look at, you know, the approach that we apply from the passive house approach, this envelope first approach, it's really finding, passive ways of reducing our load first before actively throwing technology at the solution. And so here, what we started with was really just utilizing drain water heat recovery wherever we could. And so, very early in design, we tried to locate the showers, in a location where it could facilitate the drain water to be collected in one location, so that we can then recover that waste heat and be able to then use it to kind of temper the cold water that would then either, feed up to the showers or over into a couple of tanks. And, the first stage of active form of heating is through a couple of very residential commercial grade air source heat pump, hybrid electric hot water tanks. And I'll touch on the dual benefit of these tanks, because there was a bit of another design synergy there that came from the use of these tanks. And then just to kind of touch on that, in addition to this, these tanks, the nice thing about them, great to save energy, great for storage, but they're not really great for peak loads. And in this Firehall, they're also responsible for a lot of gear washing. And so that's why a big reason for domestic hot water being so high in these buildings is not just the fact that you've got 10 firefighters that might need to take showers on a regular basis, but you also have a lot of gear washing that happens not just for this hall, but for other halls across Metro Vancouver. And so there's an extra hot water tank that's there in tandem, and that's just a direct electric tank. It's purely there for backup when they're dealing with those peak loads. And then that ultimately is the system and the methodology there that kind of serves the rest of the building. This is the one benefit that I do want to highlight here with these, hybrid electric heat pump tanks. If anyone's ever seen these, they're quite neat, right? It's just a little heat pump that sits on your tank. It draws warm air from your space in, it blows cold air out. And as it kind of draws that warm air from the space in, it kind of transfers that heat in through via vapor compression cycle into the domestic hot water that's being generated, which then serves your building. Now you're thinking, well, if this thing is just spewing a whole bunch of cold air, finding opportunities to be able to utilize that is key. And for us, particularly in a fire hall where you got IT and comms rooms, again, through some of the work that we did with the HCMA very early in the project, co-locating these rooms where you've got, cooling only process loads that are happening 24/7 allowed us to duct that cold air into these spaces and just allow for that hot air to just kind of transfer back in through that space and just kind of allow for this like passive cooling effect, if you have it. And what we were able to find is just, doing some back of the hand calcs is that, based on the amount of domestic hot water consumption they're forecasting in this building, the amount of cooling that's able to offset, because of course, we still need fan coils there. It's not like we're going to be utilizing domestic hot water all the time. There's always going to be fan coils there to help manage the load. But this approach would probably help reduce the amount of active cooling these spaces need by about 20%. Which again is over the course of a year quite substantial, considering this is a 24/7 load, which is constantly being imposed on the building. And so there you have it. Hopefully, it was a lot of information, a lot of technical information for you to kind of digest, but I'll leave it here. I'm happy to answer any questions that you might have. This is a wonderful shot, by the way, on the roof where it's absolutely covered in PV, and aside from the couple events that we have of our HRVs kind of poking through at present. But yeah, thank you.
Thanks, Scott. So take a drink and just hold on for a second. I just gotta do some thank yous. So I just posted the questions. So there's the queue that's gonna come at you in a few moments here, Scott. So just hold on 1 second. We're gonna stop your sharing and I'm gonna override it. I think everyone can see the sponsors, so hopefully you can. Everything we do at the Accelerator comes thanks to support from our sponsors. So thank you to our founding sponsors, 475 High Performance Building Supply, Baxtingui Architects, Glavel Foam and Glass Gravel, Minitaire All-in-One HVAC and Dehumidification, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, Rockwell North America, Stocorp, and Solar Windows. Our champion sponsors are Icon Windows and Doors and SIGA, and our stakeholder partner is NYSERDA, the New York State Energy Research and Development Authority. Thanks also to our patron sponsors, Air Barrier, BR Plus A Consulting Engineers, Brennan Air Tightness and Insulation, Euroline Windows, Innotech Windows and Doors, Lamelux, Sanderson Sustainable Design, and US Engineered Wood T-Stud. Thank you to our sponsors. And so now, Scott, we can dive into the questions. And first up is Hans. So we'll start with him, and I'm going to now grab all the other questions that have just come flooding in. So Hans, over to you. Han, are you there? Sorry, I didn't check to see if people are still here. And I can't see him. So
he's here, Sean, but he's muted though, but I see
okay.
his name.
Okay, no worries. Why don't we go to the next, which apologize. Let me go back. Was Harvey just left us. But both these questions are good. So hold on 1 second. Let me just pull those questions up. So Han had probably more of a question. He said, do I see a bit of the vitral Firehall by Zahal Hadi in that? I guess that's an architect. I apologize. I don't know. I think it's more of a design, I think.
Indeed.
Yeah.
That's a very good question. I think it's a better question for HCMA to answer, but
no worries. And I just had a note too, is did you have conversations with the city of Vancouver about potentially doing a retrofit to hall number 18 that had the most energy?
That's a very good question. I know that you know, the city kind of taking some of the lessons learned on this project. We're just so everyone knows, we're currently in the process of, like I said, kind of going through equipment startups and commissioning at present. And so in the next few months, the project's going to be, you know, going through its first stages of occupancy. And so I really hope that, you know, through the lessons learned that'll flow out of the project, particularly in its first year of performance, will help to inform what might be, you know, on the table for all their other fire halls that are obviously there. But yeah, I know that I've been in conversations with the chief before about, you know, what they can do with some of their other halls.
Yeah, interesting. And so yeah, so Harvey's question was the build out time, what was the build out time frame? And then again, kind of what are the lessons learned to speed up the build?
Yeah, so that's actually a really good question. Most fire halls typically see like an 18 to 20 month timeline in being able to build these out. This project in particular, because I mentioned how tight the site was, and given the fact that they had to make do with, you know, demolishing an existing fire hall, building out the temporary on the one end, and then working through the complexity of what it meant to kind of design on such a tight site and deal with, you know, mobilization and equipment laydown and whatnot, it actually took significantly longer. So the original time frame that they did have in mind was somewhere in the realm of about 22 months. But it's actually taken much longer than that. It's taken almost 3 years. And part of that has to do with COVID, definitely disrupting, you know, the flow of things. I think, you know, there's probably a good 6 months to, you know, a year of that could be possibly attributed to that. But I think, you know, if we could look at, you know, what it meant to possibly look at speeding this up, I think contractor understanding and knowledge is quite key. And so I think we all, as consultants, design professionals, and contractors, need to do more to educate one another to help understand what it takes to build a passive house from the beginning. So that when we get to, you know, certain junctures or certain elements of the design that, you know, become a challenge, it doesn't become a panic. We can find solutions, or at least bring that knowledge forward so that we can stay proactive rather than reactive to those challenges. So I think there was definitely some instances where everyone was out of their comfort element, and they were dealing with instances which kind of resulted in delays as a result of, all said and done.
Yeah, okay, great insight. Thanks. I apologize if I say this name wrong, but Gray had a question. So you can unmute. Come on, ask your question because I know it's a good one. Oh, I see that he jumped off, but his question was just again looking at the cooktop. Were they electric induction cooktops?
Yeah, I believe they were. Yeah, so that was probably one of the biggest paradigm shifts that we had at the beginning of the project, was explaining to the firefighters that they wouldn't have nice big natural gas stoves. And we had a great fire chief that basically said, we can live with that. We basically explained that they could still put in a little propane, barbecue out on their patio. And so they were happy to do that. And so, yeah, electric induction ranges were one way of being able to not only reduce the energy, but the carbon footprint as well. But it also just, reduced the burden of, having to look at much bigger exhaust ventilation rates as well. So it was, a very clear design strategy there.
And I knew Kevin would have a question, being our passive house fireman. Kevin, go ahead, fire away with your questions.
Thanks, Sean. My question was the apparatus floor included in the envelope, or was it like a separate zone? And then how did you deal with the diesel exhaust? In New York City, we call it the Niederman system, that then pulls the exhaust from the trucks when they park in. And then did you need makeup air for that system?
Yeah, great questions, Kevin. These are actually wonderful questions because we had some great lessons learned from previous, working with Dieter Lang, or I met Dieter Lang years and years ago when he was in Vancouver, and he shared with us just some insight that he had from, a German passive house fire hall that was really the only other precedent in the world of a passive house fire hall, aside from, another local Gulf Island fire hall that we worked on, which wasn't certified but built to the standard. But what we learned is that if your fire hall, or if the apparatus bays are like the storage garages are heated, then the Passive House Institute wants you to include those in your calculations. And so the fire hall that was built in Germany did not have theirs heated, right? It was a volunteer fire hall, and they didn't need theirs heated. But in our context, fire trucks and the fire halls all needed to be heated, particularly because we all know that diesel trucks, if they're kept warm, they don't have any issues starting up. And so that was a challenge that we had to get around. And so what that meant is that Passive House allowed for some exemptions around some of the air tightness requirements. However, and some of the primary energy demand, the primary energy renewable requirements, however, held the project accountable for making sure that we still met the space heating demand specifically for those spaces. And so it did mean that we couldn't just get a completely free pass on, designing that portion of the building, to be an energy hog. It meant that we had to look at, putting in better doors, even though those doors needed to be fast response doors. And so, the glazing in those doors, I believe, is triple pane. And so they were custom built doors, as well as just a more rigorous envelope all around. So there was a separate PHPP model specifically for that portion of the building, because the operational zones were actually being held at 10 degrees Celsius, which is just a little cooler, I think around 50 degrees Fahrenheit, compared to the rest of the hall, which is being held at 20 degrees on average. And so as a result, there was a different portion of the building that was included in that calculation. And I think altogether they looked at averaging them out when they presented that to the certifier. And so your last question about the Niederman exhaust, so the vehicle exhaust extraction system, that goes straight outdoors. There's no form of heat recovery. The reason for that is because the system operates just on such, short intervals. Basically, the idea is that for every time there's a call, so anytime there's a call, a truck goes out and eventually comes back, and it wouldn't operate for any more than 5 minutes at a time when the truck goes and comes back. And so in those short stints, you know, to be able to put in a heat recovery system, we found that it wasn't going to be quite as effective, or particularly from a cost standpoint. And so it's just something that was developed into the overall energy, I guess, methodology in terms of finding ways of kind of accounting for that in other parts of the building design.
Great. Thank you very much. I appreciate your insight. And if
And-
you need contractors trained on your next fire hall, I'm happy to come to Vancouver. And train them.
Yeah, and I know that you're making a special trip just to come check out this Firehall and be like, I want one of this in New York. So
I'm bringing T-shirts, and the city of New York needs to be on notice because there seems to be almost like a challenge between Vancouver and New York City on who's the best passive house in the North America. Anyone on the call from the city, we could do this here. You know, Rescue 5, Rescue 1, the new firehouses being built aren't far off from being passive houses.
Right on. That's great to hear.
well, again, it's nice that we have a North American example. And you're right, Scott, technically you have two. The other one didn't get certified, but it was definitely built with the premise of moving this thing forward, which is pretty exciting. For everyone that's on that doesn't understand why I'm at the controls tonight, if you happen to jump on a little later, Zach and the rest of the Accelerator crew, so Mike Ingwe and Shannon, are at FIASCon in Terrytown, New York. And so given that the Wi-Fi might be a little slow there, they thought it'd be wise for me to manage the controls tonight. So Zach is out, I'm in. We have Louise, who's acting as the guest host, and Scott has been providing amazing content with Firehall in the city of Vancouver. And I have to say too, is the architecture is amazing because when you drive by, they actually have 17 embedded in the brick near the top of the tower, which is pretty cool. So carrying on with questions, we have Jeff, who has his hand up. And I didn't forget about him tonight, or at least not yet.
Oh, I didn't think you forgot about me, but no, Scott, this is a great project. And my question is around the air source heat pump domestic hot water heaters that you had installed. They all require a fair amount of airspace to be in like large mechanical rooms. How did you deal with that? Was air brought in from the outside, or just what was the strategy around that?
Yeah, so so what we did is, like I mentioned in the slide, is we just ducted the cold air that it I guess it rejects directly into the IT spaces, right? The IT and comms rooms. And then by virtue of just pressurizing the space and the fan that's in there, it's kind of returning back through into the space. And so it's in its own mechanical room. It's just drawing room air from that in those mechanical rooms. It's not a huge space by all means. If I don't know, Sean, if you had a chance to actually walk through some of those mechanical rooms, they seem a little cozy. But you know, that portion of the building that they're kind of located in is there's quite a bit of space to kind of allow for the systems. And so it's just kind of inside, if you have it, the envelope of the building. So it's just drawing room air and then just ducting the air from the units to the spaces that need the cooling themselves. So it's not actively pushing out or pulling air from outside of the passive house envelope, if you have it.
So let me clarify that a little bit. So the air that was being drawn into the mechanical rooms was just done through like louvers, transfer ducts kind of things.
Exactly.
And then the air was being actually forced into the spaces where you needed to have, where that cool air was actually an energy benefit.
That's right on the button.
Okay, got it. Thank you very much.
Yeah, absolutely.
Yeah, I zipped down for a quick tour, so hopefully maybe we'll have a 3-minute video. And you're right, the mechanical rooms are quite spacious and quite well organized. So kudos to the crew and the site super for everyone to make those rooms look pretty. I mean, sometimes we in the passive community we like mechanical rooms, and these ones are pretty sexy. So hopefully we'll get that video ready for next week. Now we are over to Brandon Martin. You're next. I know, Brandon, I think you might be talking to somebody else, but if you want to ask your question, go ahead and unmute. There you go.
Hey, sorry about that, guys. Scott, thanks for a great presentation. A lot of good insight on the project over here. All of us armchair warriors sitting back wondering how we can apply this to our own projects. So I'm coming to you from the GTA, the Greater Toronto Area in Ontario. And, we have some unique climate challenges out this way when approaching sort of the high performance standards to the local municipal fire halls. So my question sort of centered around the apparatus bay a little bit more. And you touched on it a little bit in one of your previous answers. And what was interesting to me is you were noting that the temperature set point in that space was significantly lower than that of the living quarters by about 10 degrees or so. Out here, it seems to be that they want it 20 degrees in every single space. So it's presenting an interesting design challenge. And for us, when you have those minus 20 to 25 degree design days, the heat recovery in those apparatus bays when your big doors are opening and closing on calls, looking at how you address the challenge of heat recovery in an acceptable amount of time to sort of bring that back. And I guess that lower design temperature and maybe your warmer climate sort of helped with that.
Yeah, that's a very good point, Brandon. And being very conscious of the fact that it gets much colder in the Greater Toronto Area, and then also you do deal with much warmer and humid summers is a very different design challenge than the kind of very temperate coastal climates that we experience here in the Pacific Northwest. I think you touch on a very good point, which is you have to design for your own climate context. And we all being, like you said, armchair warriors in our own backyards, we know our climate's best. And I think through that vernacular of having worked in these areas as long as we have, we can then find solutions that are best suited for our climates. So the one thing I do want to say, particularly on the topic of the temperature set points that you're having a challenge with, I say, have a conversation with the firefighters, understand why they really need 20 degrees. The firefighters here, yes, it's definitely temperate, and yes, they like to open the doors up quite a bit. The one thing that we do have in our bays is that there's a big, large radiant infloor system. So it's able to, through its thermal mass, provide quite a bit of heat when those doors are left open, say for a little bit of time. So it is there to be able to kind of allow for that effect, should they leave the doors open. But I think there was quite a bit of time spent with having this conversation with the firefighters to help them understand that, you might have to treat this building a little bit differently than you would have, what your old building was, right? So I think it starts with the leadership and helping them get on board, because if they see, for instance, our deputy chief, when we help explain the benefits and how he was playing a huge role in that, for him to then share that across, his different, groups or his different squads, I think for him became, far more impactful message coming from someone like him to be able to share the importance of, looking at a more comfortable temperature or, a slightly reduced set point in those spaces. And then also, trying to avoid leaving doors open throughout the year, because at the end of the day, the spaces need to be just warm enough for the trucks to just start up, right? But I did realize that someone had actually, I know that Tyler Moore is on the call, which is, deputy fire chief here. So shout out to you for being, a progressive leader and someone who, was really open to challenging those design paradigms. The other things too to consider is that, this fire hall in the future, the city of Vancouver is looking at purchasing electric fire halls. So this whole idea of the Netterman system, the vehicle exhaust system, would eventually become decommissioned. And so we wouldn't see this huge ventilation load eventually being, an issue, so to speak, right? And so that was another big element there that has an impact on energy. But then coupling that with the fact that with electric trucks, yes, you don't want to keep them, incredibly cold, but keeping them warm enough, standard, storage garage temperatures, right, that are unheated, to be able to allow for those trucks to start up. without any issues is also another element to consider. You're on mute, Brandon.
Yeah, sorry about that. I've just had a contractor here talking to me on the other side of the wall, but thank you very much for your response. It's interesting to try and pitch an all electric building to a very fossil fuel based archetype. And when you use that in such a way to, aggressively heat these spaces that are very traditional and more industrial type spaces, to come away from that and like you said, the paradigm shift of really sort of championing this whole idea of electric and just the technology and sort of the design and using, all of these projects as references to be able to apply that to all these different climate types is just taking a little bit of time. And this is just sort of the inception of it all, right? So we're all sort of in this together, figuring out this together, because at the end of the day, the firefighters just want to do what they want to do. They want to live in a space that doesn't look or feel or act different than they're used to, or any of the halls around them. So you have to create this whole big transparent system, active and passive, and you have to deliver it in a way that looks exactly like it has for the past 150 years.
Very true. Very true. Very good points. Well said. I think it takes some time to just sit down and listen to each other's points so that you can come and find some common ground to design around.
Thanks, Brandon. Thanks, Scott. And again, thanks for mentioning Tyler. And I was going to give him praise, but now he's got his hand raised. So we'll go to him and then we'll go to some events that are upcoming. So Tyler, over to you. Thanks for joining us.
I just wanted to point out for anyone that's building fire halls and going passive housing, going away from natural gas, we were able to actually get a better emergency response sort of capability. If you're tied to natural gas, we don't control where the natural gas flows down the line. So if we want to continue to have a fire hall function as a normal fire hall, cooking wise and heating wise, we don't control it. We do control our generator. So if we have a generator on site that can control the electricity flow into that building, then we control whether a fire can continue post disaster. So for post disaster, we're moving away from all natural gas appliances based on our emergency response. Nothing to do with it's an added benefit that it's actually environmental as well, but it's mostly to do with it actually is for us, it allows our fire halls to function post disaster, which obviously Vancouver is in an area that may happen. So anyway, that's what we actually end up getting a better system overall out of having to move to this sort of new era of fire halls.
Great point, Tyler. And the fact that it's all electric, with this being a passive house building, you're effectively able to reduce that energy demand, that electrical demand quite significantly. And so with the right amount of PV on the roof, this fire hall could effectively become self-operational and essentially off the grid to some extent, should there ever be an issue. Because Tyler makes a very good point. If there's a seismic event and that natural gas main goes, then you're without heat, you're without heating. And cooking capability to do that and stay functional during those times. And so it's a very good point. Thanks for reiterating that.
Again, we always need great clients. And so Tyler, thank you for being involved in this. And thanks for showing up tonight. Again, as you can tell, the passive enthusiasts that are here tonight just love the nitty gritty that Scott has provided. But a lot of it comes down to connecting with the clients and understanding how do we provide, the passive standard to different type of occupants. So thank you very much. Okay, everyone, let's talk about upcoming events. Share my screen here. So we have the latest Passive podcast with Katrin Klingenberg. So check that out. Oops, sorry. Then we have a bonus episode from Ron Beatty. This was from the International Passives Conference from a few weeks ago that had been popping on. Zach had many conversations with many of the organizers and attendees. So check out this bonus episode that Zach and Matthew Cutler-Welsh have put together. next week, next Tuesday for most of us, Wednesday morning for others that are across the pond, we get the Passive House Accelerator Construction Tech Rural Passive House Affordable High Performance Design in Western Alabama. This one is going to be special. Hopefully you can make it. And again, if not, all of the, not only the construction tech, but also the showcases can all be seen on the Passive House Accelerator YouTube page. So hopefully you can join us because we love the questions and love to connect with all of you. So hopefully you can join us. Then next Wednesday on the Global Passive House Showcase, we get the Larch Corner Passive House plus Timber, which was the winner of the UK's 2021 Passive House Award for Small Projects. And if you haven't heard of Mark Siddle, I'm not sure where you've been. Not only was he featured on the Passive House podcast, but he's been in the Passive House community for a long time. Great insights, and I look forward to his wit and comments about this particular project. Mark this on the calendar. We have Design It, Shape It, Build It, Building Performance Interactive on the Accelerator, Thursday, October 28th, episode number 1. Mark it on your calendar. So those are upcoming events. You can always check out the Passive House Accelerator website for all that was happening, but lots of exciting stuff. So everyone, it is past the top of the hour. Oh, what's wrong, Jeff? Can't hear me? Volume okay, Jeff? I think everyone's okay.
Yeah, it's all good, Sean. It's all good.
Okay. So we're going to wrap up, but before we do that, get some closing words from Louise, and then we've got Scott. Hopefully you can stick around. We've got lots of questions, so we'll see how late we can keep you.
Yeah, happy to.
Over to you, Louise.
Again, I want to thank Passive Accelerator for the invitation, for being the guest host today. Scott, I saw the pre-presentation during early this week, last week, but it was amazing. But man, it's a pleasure to be able to watch this presentation. It's a pleasure to see the work you've done. I mean, like always the first one is always the hardest one, and then you just have to multiply and make it easier, right? Again, guys, let's keep up with the good spirit. Let's keep up with the hard work, and this group has everything it takes. Let's try to make this broader to everybody so we can actually one day make a bigger difference to our planet. Sean, thanks, man. Thanks again, everyone, and let's stick around for the top of the hour with more questions. Amazing.
Wow. Okay, this is why we always make sure people have backups, because you never know what can happen. So I think Louise was saying if you have to go, again, we understand you got other things going on in the world, but thank you for joining us. We will continue to answer your questions, and Scott will hopefully stay as long as we can. Thank you, everyone, for joining us. See you soon on the different events, and always appreciate connecting with all of you. So thank you very much. So the list of, let me just change screens. We're going to go back to the question. Jason Wen was next in line, but let me just check to make sure Jason is still here.
Hello.
Thanks, Jason. I know your question got answered, but you might have another one. So over to you.
Right. Yeah. So Scott and Tyler brought up a good point. The post-disaster building has to function even after a seismic event. So can I assume that the geo exchangers, they're meant to withstand some sort of a seismic event as well? Is there's no backup heating to provide for the geo exchanger should they fail, right?
Yeah, that's a very good point. This system, I guess, depending on how, I guess, severe a seismic event occurs and the impact that it might have on the field, luckily the fact that it's passive will hopefully be able to, manage and not need any heating or cooling, right? With enough bodies operating, and should there actually be a seismic event, I think everyone's going to be operating at full tilt so that they'd be hopefully providing enough heat in the space just on their pure body energy. But I mean, in the longer term, to your point, Jason, should there be a seismic event and it does have an impact on the field, I think there's quite a bit of redundancy in that field to allow for it to possibly make do without possibly a few holes that are compromised. Like we highlighted, there's 12 boreholes that are needed to deal with 100% of the heating and cooling demand. But that's also a theoretical heating and cooling demand, right? That's assuming a peak load, and how often those peaks actually occur all at once. And so with that said, you know, and the fact that we've allowed for, you know, a few additional boreholes, and there's actually space on the site to drill a few additional ones. I think that, you know, inevitably, should there be a seismic event, you know, there might be a couple of boreholes that could get compromised. But I believe that there's enough there's enough capacity in the field to be able to handle that. But there are a couple of connections. We didn't, you know, completely leave it out in the mechanical room. There's still a couple of connections there to accommodate a future boiler should, you know, they need it. It just wasn't installed in day one.
Great, thank you very much.
Thanks, Jason. And Stuart, always pleasure to see you. Glad for joining us and glad for putting some input into the chat. Thanks, Stuart. Next in the queue, Robert Kelly's got a couple questions. Robert, hopefully your wine is tasting yummy today.
Oh,
and good to see
it's
you.
great today.
And
Thanks,
fire
Sean.
away.
Okay, well, pardon the noise in the background, but you know, first of all, what's the roof membrane, and also the support structure for the solar panels?
Okay, the roof membrane. It's a tough one to know exactly. I want to say it's just EPDM, possibly, but I'm not the architect, so that's a great question. I think it's a good follow-up question for me to get back to you on. But the support systems for the panels. So if you recall, there was kind of the amount of PV on the building is such that there's a series of ballasted racks on the high roof, where they're all basically tied back into some discrete points, thermally broken points into the building structure. And then there's a portion of the building on the north end that's actually on the higher, it's a bit lower. And so there's an elevated steel structure that brings it up to the higher point of the roof. And that's thermally broken from the building structure and tied back into the building structure as well.
So would you say that, so they've got basically a rack that they've got pedestals that are sitting on top of the EPDM roof so that it's elevated up and it's just sitting on top of the roof? Is that what you're saying?
Yeah, and then there's
Okay.
in order to kind of seismically, you know, restrain it or brace it, it's tied in at very discrete points, and those connection points are thermally broken.
Oh, that's cool. Because see, when I get into these flat roof buildings that we do in Chicago, I'm always thinking about maintenance and how do we maintain these structures when we put so much stuff on top of them. So I would love to have a great system to be able to start putting PV on top of the flat roof buildings we do, but just looking to see what you guys are doing. That's all.
Yeah, so I mean, that's a very good point. You know, I know our electrical team who'd worked on this worked very closely with the City of Vancouver's facility teams to make sure that there was enough maintenance access between all the panels. So each one of those panels can be accessed. They can be individually pulled out and maintain if needed. So there's plenty of access around the perimeter of the roof itself and between the panels so that each and every one of those panels can be accessed. The other great thing too is that there's nothing up on the roof except for those, aside from those and some vents. So really, you know, in terms of getting up there for maintenance access, there's no other mechanical equipment up there. Which really only leaves it to the panels themselves. So kind of speaking to that, you know, looking at the roof system, I know that, you know, when we were talking around this is a great question for HCMA because I know that when we were working around the design table, again, we were talking about this building having a much longer lifespan than your typical building. And so we needed to make sure that, you know, even with the roof, it was going to last far longer than, you know, your average roof would. So I think they worked really closely with RJC, the structural engineers, and they were also the building envelope engineers on the project to hopefully design a detail that's bomb proof.
Cool. Well, nice job. It's a beautiful project.
Thanks.
And Bob, I was there today taking some video, and so I don't want to screw things up where I get conked out again, but I will hopefully have the video up for next week, where you can see the two different types of solar panels and how they're connected. And you know, we do say it's a flat roof, but you know, it's Vancouver. We know it rains, so it's more like a 3-degree roof. Okay. You
Yeah,
deal
oh.
with 0-degree roofs in Chicago. We don't have that here in Vancouver because we know here water's coming and it needs to get out, right? Like when we talk about building science, rule number one, bulk water, keep it off our buildings. So,
Yeah.
Make it go away.
And that's actually a very good point. You're right, Sean. It is a sloped roof. It is sloping all towards the north, so it actually pulls all the rainwater and scuppers it down so that all the rainwater leaders aren't actually penetrating through through the passive house enclosure that is kept at 20 degrees. It's all kind of running through into the portion of the building where the apparatus bays are, which is only 10 degrees. So it really limits the impact of the thermal bridge there and avoids it from having a negative impact on the portion of the building that has a higher demand from a passive house standpoint.
It's got one last thing. If I could jump in real quick, is that what's the roof deck made out of? Is it wood frame and plywood sheathing, or is it metal trusses?
It's steel.
And
it's
steel
steel
deck?
frame. Yeah.
Do you guys have a issue about managing condensation with a metal deck over the insulation?
That is a great question for our building envelope consultant on the project.
Okay,
Yeah, Bob,
let's get that guy on the site.
Yeah, we'll get him. Don't you worry. But again, there's a lot of insulation above the steel. So just, again, we talk about a lot of times the steel being a massive thermal bridge. There's a good sweater on that roof. And, it's funny. Every time I drive by Knight Street, I always stop and take a photo. So I've got a good collection. I think I probably have more than Bill, who's the site super, because every time I go by, I'm like, oh my God, it's coming together. It's so cool. It's a very interesting shape, which causes very interesting details from a construction and durability. And, I think there's one point too where the exterior plywood had fire coat added on. And so you're just like, why is the plywood look pink today? And because they're doing different things. So it's a pretty cool project. And a lot of the part of the project though, again, is Scott and the team at Integral with the amount of work that they do with the mechanicals. Like there's a lot of pipes in this building, and everywhere you look up, you're like, oh my God, like there's a lot of flow going on. So great stuff. And we'll get more details. Well, one of this point too, we'll get the architect on. So yeah, stay bubble. I'm sure you'll have some more questions. Sandra has left. I'll find her question. Peter, you said your question's answered, but I'm sure you have other things to ask. So Peter, Peter, your mic's doing its thing again where we can't hear you. Pull. There we go.
Is that better audio? Has it changed? Good. Earphones. The roofing question. As a former roofer and concerned how the penetrations are, and well, you've already explained that. Thank you. What about the tower for drying the hoses, hanging up lengths? How did you integrate that?
From a system standpoint, so that the tower itself is part of the operational portion of the building, so it's not kept at a full 20 degrees. It's similar to the rest of those kind of bay areas where it's being kept at 10 degrees. So it is the structure is integrated into the same structure that connects kind of the basement level, which is below grade, all the way up. But where it does, I do know that I remember talking to HCMA about this, but where it does in fact butt up against the portions of the building where you have the portions of the building that are being kept at 20 degrees versus 10, there's a significant amount of insulation and thermal bridging kind of details that have been developed to help mitigate that impact. And so I'm trying to remember exactly what the effective R value of that wall is, and I'd have to look it up, but it was essentially like I want to say it was like an R20 or R30 wall in effect to some extent between those two spaces.
Yeah, I think, Scott, when I saw it today, I think it was like an R30 given the thickness of the rock wall that was there. Again, there's some steel in there, so it might be reduced, but it was pretty thick. But also too, the doors that go from that section into anything else, they're high performance. I mean, like
they're all passive house rated doors. You'd be amazed how many passive house doors there are. And part of that was also because of the fact that you couldn't find any fire rated doors that were passive house rated at the time when we were designing. And so you know, to some extent, there were some instances where we had to create a bit of a vestibule condition where the passive house door was there, and then the fire rated door was on the other end to allow for just the ratings to be carried on. And so very, very different circumstances. I know there's a lot of architects probably that could, you know, highlight the fact that there's fire rated passive house doors that are probably available now, so put us to shame. But you know, it speaks to a project that was doing a lot of firsts, and the solutions that we had to come up with, you know, at the time of design.
Yeah, the second one will have a much easier time than the first one, but hey, got to be leaders.
Yeah, for our pole holes, so when we go from a conditioned space into a non-conditioned space, or a you know, 20 degrees to a 10 degrees, we had to have the fire rated door and the passive house door sort of separation between those two. So one door will be held open all the time unless there's a fire, and then it can be released, and then the passive house door to keep the passive house certification in place.
Yeah.
Thanks, Peter. And David, you're next.
Okay, thanks, Sean. And thanks, Scott, very much for the presentation. That was great. Love all the details. I just want to go back to the very beginning of the presentations. You said you were doing a carbon net zero. So I really have kind of three questions. So I'm going to squeeze those all in. Sorry, Sean. One is what the carbon intensity. So how many tons per carbon per square meter per year? How are you offsetting it? And what's the cost of your offsets?
The first one, based on just a few fire halls that I've worked on where they were all electric, what we find is the GHGI, like the GHG intensity on these buildings is often kind of hovering around 2. It's incredibly low. And I wouldn't be surprised if this one, I don't have the exact metric in front of me, but I wouldn't be surprised if it's actually closer to 1 or maybe even less than 1. So, you know, we're incredibly, you know, blessed to have very clean electricity here. So it significantly reduces our carbon footprint when it comes to utilizing electricity on our projects. So what that means in terms of tons of carbon, I think when you kind of look at the scale of the project, it's not very much. You're probably looking at the equivalent of like maybe like, you know, probably about 19 or maybe even less than that, right? 19,000 square feet. So maybe about 1,900 square meters. So it's just actually just under 2 tons of carbon on a yearly basis. And so what does that mean for offsets? Well, there's enough PV on the roof to hopefully offset a significant portion of that. So really, you know, with the cost of offsets these days, they range, you can get kind of lower grade ones at, you know, I think it's like $4 or $5 US dollars per ton, all the way to the higher grade ones, which are anywhere between kind of $30 to $50 a ton. So, you know, if you had to guess, probably in the range of anywhere less than like, you know, $100 worth of carbon if it needed to be fully offset. But like I said, because there's a substantial photovoltaic array on the roof, you know, it's taking, you know, the brunt of the load. So I wouldn't be surprised if the equivalent carbon offset is like, you know, in the dollars, kind of less than, you know, $10 or so.
Okay, I'm going to jump in there thank you very much. That was great. Any batteries in your PV system, or is it just straight? No batteries, just straight to inverters.
And David, we technically know that the future electric fire truck that's coming is the battery. So, you know, it's coming.
Yeah, great. Thanks very much, Scott. Thanks, Sean.
I just see that Scott jumped on a call, so we'll come back to him in a second. I'm just going to see if A. Conrad is still with us. A. Conrad, you want to ask your question?
Sorry, what was my question?
That is a good question. 1 second, I will go find it. Where did it go? Oh, you asked, what is the average distance a fire truck has to travel? 10 kilometers, 20 kilometers, totally EV ready.
That's correct. Thank you.
That is a great question for Tyler Moore to help take here.
Yeah, so ours is, 10 kilometers is very far. What I can tell you is Berlin and Amsterdam and Dubai have Rosenbauer electric truck that we're getting in service right now, and they run 96% on battery alone. So that the unit will get, we're expecting that. So we expect about the same capabilities, is running full EV 96% of the time.
Wonderful. Thank you very much.
And you said too, is again with the batteries, dealing just with pumping water is the big draw on the truck and the battery.
Which is yeah, so NFPA requirements. So to meet NFPA, which is our National Fire Protection Association guidelines, 4 hours of pumping needs to be accomplished, and it wouldn't be able to accomplish that. So that's why we have a range extender BMW 350 horsepower diesel engine that can be used not only for if you run out of batteries to just drive, but you can move that and use that for pumping.
Did you see my other comment? Because I actually figured, so since we have hydrants all over the city, why don't we just bring electricity to the hydrants? So basically you have a hydrant that you plug into for water, and why don't you have a supercharger 10 feet away that you plug in for electricity?
We could. We're currently doing a supercharger at one of our firehalls for this particular unit, and it's $450,000 to put the super unit in, because we have to get a whole new power supply for it. So okay, it's a little cost prohibitive to put at every fire hydrant.
Hey, we'll talk to Chris Higgins. Come on, just take her.
We got 6,000. We have 6,000 hydrants in the city.
Well, and you know how the city went well with the parking issue in the climate emergency plan 2 weeks ago. So yeah, I don't think that's going to happen too quickly.
No.
Okay, Scott's still on the phone. Let me just see. Sorry, who else is in the queue? Who else do we? Oh, Jeff, did you have any other questions? I have you down as in the queue.
Yeah, I know a couple questions. First of all, I just did the quick math, and 6,000 hydrants times $450,000, at least American, is about $2.7 billion. So that's a little on the high side.
Not going to happen. Yeah.
So, anyways,
no, but I mean,
simply this.
Yeah. Here, there are there's there is electricity all around the city. So pulling a wire from the overhead down to cannot be like that is a one-time cost for a fire station. But when we get into the Elon Musk kind of economics, it'll be $40,000.
Well, most light posts have a connection. You just got to pop off the cap and tie into. It just depends on, you know, what part of the city that was pre-done for. But
exactly. I don't know why all light posts are not EV chargers yet. So that's
getting there. You know, baby
steps. That was not my question. That was just an interesting aside. My real question is for Tyler, which is that how did you monetize the response criteria of your application? Because so often it comes down to, you know, these other benefits that the passive house design extends, and so how did that work, sort of convincing the naysayers that these were the right investments to make?
Well, the city of Vancouver is green, and we had a city manager, Sadhu Johnson, who was basically like, you know, bike lanes are going in, naysayers, doesn't matter, it's going to happen. So greening of the city of Vancouver was highest priority. It is the number 17 Firehall, as Sean had said, it's on Knight Street, and Scott had said it's on Knight Street. It's the first civic building you see when you come into Vancouver from the south through the Knight Street corridor. We wanted to set the tone of the city of Vancouver to be a green city, greenest city 2020. That was what we were striving for. It was part of that sort of idea. So yes, and there's a cost to doing this, but we and the city believed that it was worth doing and setting the tone. If others are asked to do it and cost a bit more money, why are we not doing it as a city? So
okay, so it was more just civic
policy,
responsibility
yeah.
for that.
Yeah.
Jeff, one of the reasons when we talk about Vancouver being a leader in passive house in Canada and North America is, we had a mayor for 10 years that just pushed the whole Greenest City initiative, and that opened the doors to a whole bunch of different policy, which is great because it, like as we talked about on previous shows with BCIT's Tradesperson course, City of Vancouver supported that initiative immensely. And so you have the City of Vancouver daycare project that hopefully we'll showcase soon enough. This particular project, there's some really exciting things coming for Vancouver. We're lucky now that we're seeing more finished buildings. Again, the art studio on Pacific Street is now completed, and that's a 9-story, so that's kind of a bigger one in Vancouver. So we're now, a lot of these buildings have been in the books for a long time, and I mean, as Scott said, 5 years plus on this particular project. And Stuart, you're on too. I don't know how long, even before Scott was given this project, how long you were involved in trying to get it. So it's great to see these projects starting to get ribbons and get people occupied in these. It's great.
So I just want to add one thing is I live in Lexington, Massachusetts, which is just outside Boston. And I honestly can say that from my perspective, Vancouver is what Boston is trying to mimic and attain. And we're on the cusp of a mayoral election, which is truly historic. And so my hope is that we can follow your lead. And so thank you for giving us a tangible example to follow.
Yeah, thanks, Tyler, for being involved in this. It's great. And again, Jeff is like, we're following Europe and we're behind. So if we're a leader, it's great because we have other leaders in Europe that are setting examples. So we're, again, I think the way we say we're sitting on the shoulders of Titans. So we just got to keep moving this thing forward.
So here, one last quick question or quick point to make is that I think it would be a great accelerator session to have a whole bunch of fire chiefs together listening to this one presentation. And Tyler, if you would be amenable to just advocating the benefits, it would be great because fire prevention and safety are a huge driver and a public driver, and it would be a wonderful a presentation to listen to over and repeat over and over.
I'd be definitely. I've talked to many fire chiefs and mayors from around North America because it's for this particular project. I've also talked. We also for land use, we actually have built a fire hall that has 4 levels of women-led housing, YWCA housing on top of our last fire hall we built. So we're also leading in usage of land in co-location sort of aspects as well, and that's another one that fire services are looking at doing as well, because then you're utilizing the land that the public safety is using it, and not just for fire hall.
Well, public safety is a universal message.
Yeah. Well, again, thanks, Scott, for delivering such a great presentation that we can copy and paste and give to Tyler and the rest of the fire chiefs across North America. So this has been a great night. Stuart, I think you had a question. I know I got Jimmy with his hand up, so we'll go to Stuart first, and then we'll see where Scott's at. So
yeah, it was just a quick question for Tyler. If he knows how big the battery is on the on that fire truck. Just trying to compare it to my Tesla.
We have 250 kg. I think they're so it's 100 altogether, which is not massive in my understanding of it.
Yeah, but I guess if it doesn't have to go 500 kilometers, it doesn't matter, right?
Correct.
As long as you've got the power to get you 10 kilometers or 20 kilometers. It's
yeah, and so it can go about 100 kilometers on that. But it's so fast, they had to tune it down. It's got 4-wheel drive, 4-wheel steering, and it can raise 20 inches off the ground, so it can go through water, or go down so people can grab equipment off of it easily.
Who's the
Everybody wants to
manufacturer?
drive that one, eh?
Yeah.
Yeah, I was gonna say, sounds like a fun little toy.
Yeah, so it can get out of traffic. So if you're stuck in traffic, you can just turn the wheel sideways and go sideways out of traffic.
Which hole's that one going in,
The
Tyler?
number 6 Firehall. So it's
Number 6.
down at Nelson and Nicola downtown.
Nice.
Okay, cool.
Just something I wanted to share. I know I'm so glad that Tyler was able to be on this call because, you know, you can clearly see how a lot of people just have questions about, you know, just the intricacies of you know, the complexity of a fire hall and how some of the decision making on this project, you know, kind of flows through Tyler. And I want to definitely, you know, provide a shout out to Tyler because he was there at a lot of the design reviews, a lot of the, you know, meetings at the onset of the project where we were having those specific conversations around paradigm shifts. And Tyler was really a great sport and, you know, they're listening to everyone, challenging us when needed to make sure that we weren't kind of, you know, we were not only allowing for a very, you know, sustainable building to be built, but then also finding ways to keep us humble because at the end of the day, we're still building a fire hall and operationally, you know, response time, you know, is critical. Another thing that I also wanted to layer in is, I mentioned this at the beginning of the presentation, but in the past when we had done this presentation, I did it, you know, in conjunction with HCMA as well as Craig Edwards from the City of Vancouver, and really we provided a bit of that narrative for the audience to understand, you know, the city's, you know, from a policy side. Craig pointed out, you know, the city's, you know, evolution through the green building policies that were enacted. That eventually led to some of the transformation, you know, from, you know, LEED to eventually passive house being mandated on all municipal projects, and you know, touches on a lot of the projects that kind of came and flew or came out of that, right? And then eventually HCMA touches on some of the intricate, you know, design elements from an architectural standpoint, which I know a lot of people have, you know, questioned on, and then obviously on to us to address the energy piece. So you know, to that point, I think, you know, it'd be great to kind of reinvigorate that conversation. And I'm really looking forward to this project being complete so that we can actually get some real data about the consumption and energy to be able to share. And I think Tyler would be a great person to have at those conversations because, you know, when we finished building Hornby Island Fire Hall, you know, I was having almost monthly chats with the fire chief there, Doug Chinnery, and he was passing along his hydro bills to me to share and show that, you know, the PHPP modeling assumptions that we had did were kind of bang on, all while, you know, hearing from him how comfortable and happy he was in his new hall, which, you know, was a great experience, right? And I'm hoping that we were able to replicate that, albeit in a slightly more complex context here for Tyler.
And Scott, thanks for your kind words. I also want to say, you know, for anyone that's listening, that's going to have conversations with others that have, you know, different needs. All of our operational needs were all met. So that's why, so you can do this with meeting the operational requirements. It wasn't easy a lot of times. We had lots of conversations back and forth about how to accomplish our goals, but they were all met. You know, our staff is really looking forward to moving in there, and I really. You know, the whole team all did come together and made sure that what we needed, and it sometimes flew in the face of energy consumption or energy reduction, but they were able to make the offsets work. So thanks to Scott for working with us on that.
Excellent stuff, you two. This is great. Scott, we still held you in the queue. Hopefully your client's happy, and you go ahead and ask your question.
Thanks, Sean. Yes, trying to deal with clients. Anyways, I was just curious, is now that we have the sand and heat pumps available, would you have just used the sand and heat pump and put the heat pump right in the IT room and saved all that ducting and all those other issues?
Are we referring to the bigger models, right? Not the little residential grade units, right?
Well, I don't know that there are anything but the residentials available. Yeah, I mean, there's a couple of really big ones, but I would have thought the hot water demand wasn't that high in a hall. It's showers and yeah.
Yeah, no, you'd be surprised how high the demand is. And like I mentioned at the beginning of the in the presentation, you know, this fire hall was one of few that was actively going through and ensuring that there was a gear washer installed there, because I believe, Tyler, if I'm not mistaken, what you were doing is you were kind of sending this out to like a contracting firm that would pick up your gear, wash it, and then kind of bring it back. And then eventually what you were trying to do is in all your new halls is put in, gear washers. But then what that meant is now everyone else's laundry is kind of flowing to the few halls that do have them installed. And so, inevitably this hall would be seeing a bigger laundry load at the beginning. And then eventually as more halls would have these installed, it would kind of take the edge off of the laundry load. So, I mean, aside from that, considering that, you have 10 firefighters that, between the fact that they're often working out every day, so inherently taking showers, after a workout session, or maybe even after they wake up. So there's just and then also a lot of the cooking that occurs in the halls as well. I think that right there is big testaments to why there's slightly higher amounts of domestic hot water use in halls. And one thing that, also, although we're not doing that here, but some other halls, they use hot water just for like washing trucks, especially in colder climates where they need some warm water to help wash out ice and snow. So though we're not necessarily in a position to do that here, that kind of also contributes to the high domestic hot water load. But circling back to your question around, why not just use the Sandon units? At the time when we looked at the Sandon units, they kind of had the same issue as just the hybrid electric units, in that, they're able to meet a small enough load, and you have to then rely on storage to make up the remainder of your demand, right? And so, I know that when we were working through design, we were kind of fighting for whatever mechanical space we could get. We knew that, to just put in, the CO2 heat pumps, we probably, not be able to quite make it, quite be able to deal with the entire load that way. But the other thing too is that with those units, they want to be exchanging heat with the outdoors and not necessarily within the bays themselves, because then they'd be posing, an issue from a noise standpoint in the bays themselves. And the other item that I highlighted at the beginning of the conversation was that we really were trying to avoid putting equipment outdoors, not just from a maintenance standpoint, but it was also just the noise mitigation. The Knight Street is just, such a noisy corridor, right? And the residents that live in that area, it must be pretty painful for them having to hear like semis like roaring past and slamming on their air brakes regularly. But I was just in there the other day, and I was telling Stuart this actually. I'm digressing a bit from the conversation, but I was just up in the third floor fitness area, and though the door didn't have the actual latch to fully seal it off, the difference was night and day with the sound, that was kind of transferring over. And this is something that I'm really hoping to do, is once the project's completed and commissioned, I really want to go take my audio reader at the corner of the project, and then just go up to that floor and just be able to see the difference there. But I think aside from that, being a good neighbor to your neighbors in that region, the avoidance of putting any heat pump units on the roof that would then kind of be blaring noise and to the single family homes in and around the neighborhood is kind of the goal that we were trying to avoid, was potentially mitigating that issue.
So was it, like, I was thinking putting them in the server room or something like that, but is that a space that is noise sensitive as well?
Oh no, and not in that, not necessarily noise sensitive. I think there's a space issue just in
Space
those rooms.
prohibitive.
Yeah, space prohibitive. It's definitely very tight up in that mezzanine space where those units are. But I think, yeah.
The other factor there, I think, Scott, is the Sandon units need domestic water piped into them, and we don't take any domestic water or pipe services into IT rooms that are serving critical communications infrastructure. Right, those rooms take all of the noise from the tower, from the all of the communications from the antenna. So that's that's a hub for the city there, and it's
that's the best reason I could think of, Stuart. Right there. Don't want to bring any water into the computer room. That makes sense.
Yeah, no, that's a very good point too.
Yeah.
Noise mitigation was one of the things we talked about early on in the project. Knight Street caused our staff to have after calls and then have all that constant noise was disturbing for them, so they couldn't get proper rest and relaxation. So that was one of the things. Putting them on the deck right outside of their resting areas was not something we wanted to consider. So that's another reason for our electric fire truck, is to mitigate that noise, that constant noise that they're under, the stress that the noise caused. So noise considerations was a large portion of the new hall being built right on night, and how we mitigate that, plus all the equipment that goes along with it.
Yeah, I live about 3 blocks off Night, so I have a pretty good idea what you're talking about.
Well, yeah, and on the north side, I mean, there's some Vancouver specials that are literally 30 feet from that building. So, I mean, it's close.
But I think the noise that Scott was referring to was actually the noise at night, right? So when the neighbors are sleeping or when the firefighters are sleeping, you don't want the heat pump from the roof, you know, if the windows are open. You know, even though it's really busy during the day, the noise does drop down at night. And that constant noise that comes off a heat pump is something that, you know, other residential neighbors or the firefighters wouldn't want to hear, because their windows do open onto those roofs. So it's
yeah.
Stuart, you don't call that white noise yet? Is that not the right decibel for white noise?
We put a heat pump out of new Firehall. We did a reno, took a gas furnace out, put a heat pump on it, and we're already getting neighbors complaining about the noise that happens all the time. So.
Yeah, the advantage of the Sandons, though, they're about half the noise pressure of your typical Mitsubishi heat pump. They're quite low. I'm about to put one in a side yard with a neighbor, so we'll see what happens.
they are very low. I mean, I think I wouldn't be as concerned about the Sandon units. I think for them, though, for us, it was that waste heat that was in those electrical rooms. We wanted to capture that. And you know, the Ream units are much simpler sort of install. It all comes packaged. There's no piping to do. It's just a little bit of sheet metal from one room to the next. So it looked like a neat solution for us.
Yeah, no, made sense. That one makes sense. Thanks.
Mm-hmm.
Great, thanks, Scott. And other Scott, when you go to do that test on the sound, I will buy you coffee and invite me, please, because that's the stuff that is it's just cool, you know, to really get that effect of, you know, I know we've got some different images where people close the door and you go from loud noise to just quiet, and just, you know, all this stuff is fantastic. So look forward to that. Sorry, Jimmy, hopefully you're still here. I know you had your hand up, but did you have to run? Oh, there you go. Again, I don't know if you had a question or a comment. Go ahead. The floor is yours.
Hey, everyone. First off, thank you. I really appreciate it. I've been multitasking a little bit, so I'm going to flip the camera around. And I don't think anybody's actually going to believe me on this, but so I playing with the kiddos, my son goes, this fire truck is electric. And he goes, right here. I said, what's this? And he goes, that's how you charge the batteries. and he goes, the batteries are in those holes right there. So here's your future engineer to solve your battery issue.
Excellent.
Awesome.
Congratulations. Cheers.
Yeah, it's been in my ear, so he has no idea that we've even been having this conversation, and all of a sudden he's talking about a battery powered fire truck. So thank you again, everyone.
Scott and Stuart, give that kid a scholarship and hire him now. That's great. Thanks, Jimmy, for sharing. You know, this is why I love the after hour, because you just never know what's going to happen, and stuff just sometimes hits you and warms your heart. So that's just great. So excellent stuff. Well, I think we have hit all the questions, and 45 minutes after the hour. So Scott and Tyler, thank you for sticking around. Stuart, thanks for chiming in. If we missed anything else, put your hand up, fire it in. Otherwise, we'll wrap it up and let everyone go on to your evenings. And great insights altogether. Thank you guys so much. Again, I was lucky for a quick tour today. Bill, who's a site super, took the tradesperson course 2 years ago.
Yeah.
And luckily that I remembered, and I was like, hey, remember I was your teacher, can I get a quick tour? He's like, you need to go through like the whole proper, and he's like, well, if you come with me, I can show you around, and then you don't need to have an orientation. I was like, can we do that? I'm like, I just want to see one mechanical room. And then of course he's like, well, here's one. Do you want to see the other? And I'm like, I will see everything you want to show me, as long as you're not taken away. And so the fact that he knew how geeky I wanted to dive into things. He gave me a pretty good tour. Perry, we'll come to you in a second. I see your hands up. And hopefully again, we'll turn things into a video. So interesting though, again, his struggle as a site super, and I think we're seeing this more and more, is the general contractors are signing up for the tradesperson course. They're getting it, but the site supers literally are no longer site supers. They're educators because they're constantly educating all the sub trades. I think he said the electrician, it was a third site super in for subcontractor. And he's like, like I'm just constantly just don't puncture the air barrier and slapping people's hands because they're not paying attention. We'll come back in a second. Perry, go ahead. You had your hand up.
Well, first of all, a shout out to Scott. We've known each other for several years, going back to Living Future Unconferences here in Seattle. It's great to see you.
Yeah, great to see you too, Perry.
You've become a leader, man. You definitely have. And the intersectionality between building electrification and transportation electrification. This is a huge piece, especially in existing buildings, and the increase in infrastructure that's required to make that happen is something that you really need to get a handle around at the beginning stages of planning for either of those steps, because ultimately we need both of them to happen. So especially where you have fleet vehicles collated with your buildings like you do in fire stations. Thank you.
Yeah, we're actually looking at for our next one, having it so you can drive induction, like basically drive up and like buses are going to be having, so you can charge the batteries, just drive in, charge the batteries, drive out. And so anyway, that's next gen Firehall to have that for our electric fire trucks.
Fantastic. I know Europe, they've already started doing some of those with.
It makes sense.
Just for those folks in the stateside, when we get these infrastructure dollars coming down, seize the day to get the cost premium to retrofit an existing building for both the electrification of building and vehicles is a handful, right?
Yeah, thank you, Perry.
Thanks, Perry. And again, Scott is turned into an amazing educator. And again, glad he's part of the tradesperson course at BCIT. And as you can see, he presents very well. So thanks, Scott. Kevin, maybe I'll let you wrap things up tonight.
My question was for Tyler. Are you guys going with the Rosenberg electric rig or?
Rosenberg, yeah.
They just did like a Northeast tour, but I didn't get a chance to look at it. But we'll see if it comes. But
we're going over to Austria in 3 weeks to finalize the contract or finalize the specifications and look at LA's rig. LA's rig's getting built right now, so and then we get to go to see Berlin to actually see it in action and talk to the Berlin fire how it's going for them.
Wow,
that's awesome. Great. And do they, just out of curiosity, that's a pumper. Do they have any aerials that are being made, or not really, right?
Not at this point, yeah. But what has happened is now 3 major vendors are now electrified. So it's really we got in it early when there was only one available, and we were able to just sole source because there was no other ones. And boom, all of a sudden the vendors are all over the place. So it's amazing. You really have to push the envelope because vendors won't build something unless people are going to buy it.
Yeah, very good point, Tyler. And I think that actually is a really good point. Like we were constantly, I know Tyler's getting all the questions now, and it's great because you could see that everyone's really getting keen to find out more about fire halls and the different technology that's going into them. But to that point, when we started working on the project, like I mentioned, there wasn't a large landscape of passive house certified components and particularly ventilation systems that we saw as an option here. And so it definitely led us down the path of kind of finding only the few that were there. But we as advocates have never stopped advocating to the various different equipment suppliers to say, look, these Swagon units are going into this building and you don't have an equivalent, and so they're just going to gobble up all your market share. And as a result, in the past few years, we've seen a huge transformation occur. And it's largely come from the fact that we're, the city of Vancouver being a leader in their regard of kind of mandating passive house on their municipal project, but then also seeing just developers taking on passive house in their own realm has then kind of led to this transformation where, people are realizing, well, we need to get in on this action, right? And just, not in any way bad mouthing Zen or anything, but they actually have bigger units. They're just not available in North America. And as much as we were trying to kind of get them to bring them to North America and say, hey, expand your product offerings, they were like, you know what, North America, we're happy in the residential realm. So I think, now that we're seeing bigger and more complex buildings coming online and going passive house, it's great to see, industry respond to that and see a lot more options available, because especially for cities, it definitely kind of reduces that risk of sole sourcing equipment, which then drives prices up, which obviously no one wants to be, in a position of, right?
Great stuff, Scott. Sorry, I just was reading a couple comments. Mike, Lynn, you can fire away your question, then I'll answer. I got one from Patricia and Derek. So, oh, did Mike hop off? Okay. Patricia asked about some structural details on the exterior walls, and I think what we'll have to wait is, Scott, we'll have to get you to come back in a year's time, and with Tyler, you guys can give us the recap of the full lessons learned of the full year of operations, and again, get one of the fantastic individuals from HCMA to come on too, and they can talk some architectural stuff. And because it's funny, I was trying to think of when you gave this presentation last, I think it must have been a ZebX event or something, because that's
it was a ZebX
event. Like a year or two ago.
It was quite literally almost a year from now, or a year ago to the date. Yeah, I think it was end of October 2020.
Gotcha. Sorry, Mike doesn't have a microphone, but his question just was brand of HP water heaters and how the side faces of the big doors were sealed. And I know I saw the doors going in, and again, you couldn't see the daylight on a typical garage door, so they're pretty skookum.
Yeah, so the seals on the big doors, that is a good question. I'm not 100% on that. I know that they were custom doors. That I do know. So
local installers, out of town doors. Because I can see that they were tweaking a few things, and
the weather stripping or the air tightness of it is that's a Billism. Bill came up with the answer. So whoever taught him did a good job.
Well, and it's funny because I think in the past, again, I'm not taking credit for it because again, there's lots of instructors, but we did highlight the passive house that was up in UNBC, and it had one of a garage door that was brought in for Europe, and so maybe Bill was like, okay, well, I've seen something like this. How do we make it skookum? But I think you're right, Tyler. I think maybe in a year we're going to talk about all the Billisms that came about, because there's definitely a few things where he pointed out, and I was like, well, that's a hack. There's a PH hack right there.
Yeah, because I think the one thing too about that UNBC project is that large door. I don't think anyone talks about how long it takes to actually open it and how many people they actually need to be able to move that thing across, because it's massive, right? Yeah. And it's the one big opening that they do have in that building, right, aside from like the man doors. But I know that one of the key requirements here is that when they open the doors, they need to spring open right away, and so you couldn't find passive house rated garage doors that had those same response times, right? So definitely a bit of a hack there to find a custom door or create a custom door particularly for this specific project.
Yeah, I know. I asked Bill, what's his plan after this project? He's probably going to retire. And I'm like, no, you're going to become an educator. We're going to figure out how to pull you to keep going a little bit longer, just to keep all the knowledge you did on this project. So
yeah, I offered him another Firehall. He declined.
I know. We have to figure out how to get him back, just to even be a co-site super or something. I'm like, well, you technically been an educator for the last 3 or 4 years in this project. Why would you think that would change the next one? Just hire a site super and you can, be that liaison. Like, what job title do you want to have? We'll give it to you so you can keep this thing going. So, just work part-time. And so we'll see. Maybe we, offer him golf on Friday or something. Maybe he'll take it up. So, great stuff. Well, again, we've got an extra bonus hour out of this. Again, I appreciate everyone for sticking around. And again, Scott, fantastic. And Tyler, again, great insights. And I can't wait to see the ribbon cutting on this when it's getting close. I know Bill was saying 4 or 5 months, maybe 6, depending on a few other things, but it's coming close. So it's great. So That being said, everyone, we kind of gave the events. You've got BS Fridays BS and Beers tomorrow. If you wanted to learn about some of the educators that are going on, you got Mark, who's a co-host of the Construction Tech, has BS Fridays. He's going to be having Auction 8. So James Dean, who built Passive House in West Vancouver, that again, Integral was heavily involved in that. He's going to be talking more about ventilation on Friday, but we might be able to ask him too about some of the cool things going on in his house. Then next Tuesday, we're back with Construction Tech. And again, next Wednesday with another great showcase. And always, if you're bored, lots of great stuff on the podcast. And of course, the YouTube channel where all these recordings. And again, I think we're on week or episode 78 of the showcase. Pretty crazy. So thanks for joining us. Have a good night, everybody. Appreciate it.
Bye, everybody. Thank you so much.